everyone. So we're going to be doing our second lesson this week on slope as well. So we just did lesson 3.3, which is on rate of change and slope in calculating the rate of change using rise over run. Today is about the slope formula. So before I jump into today's lesson, I just want to recap lesson 3.3 very briefly. Okay, so I'm going to do that. So last lesson, we learned that rate of change is a ratio, right? It's a ratio. What is a ratio? Ratio is a comparison of two quantities, okay? So it's a ratio that shows how our dependent variable, which is usually y, changes with respect to our independent variable, which is x, okay? On a graph, specifically on a graph, we refer to rate of change as the slope of the linear relation, okay? And the general formula, right? Rate of change is simply change in dependent variable over change in independent variable, okay? So in lesson 3.3, we saw that when we had a graph, we could determine the slope of the linear relation visually, right? So recall that we use a lowercase m to represent slope. So please don't use a capital M. A capital M represents something else that we'll learn about later. So we use a lowercase m. And we learned, right? Didn't we learn that m is, if we talk about our dependent variable, and our dependent variable is usually y, our vertical change represents our rise, okay? And the horizontal change, which is our independent variable, our x value, right? Our horizontal change represents the run, okay? So what we would have done before is we would have just counted or calculated, how much did it climb, right? So how much did it go up? Oops. How much did it rise? And how much did it run, right? Remember, we did that. So that's how we calculated slope visually, okay? So today we're going to learn how to calculate slope when we do not have a graph, okay? So we're going to be using something called the slope formula. Now notice, right, the only thing we really needed to find slope, all we needed was to know 2 points that are on the line, right? That's all we needed. From those 2 points, we can determine slope. Okay, so that's what we're going to be using. We're going to learn how to calculate slope when we're given 2 points, 2 coordinates. Okay, so let's jump into today's lesson. Okay, so the slope formula, again, it's used to find slope between 2 points. Okay, right? Used to determine the slope between 2 points, just like here. The slope between point 1 and point 2. Okay? So, if we know that when we talk about ordered pairs, right? Ordered pairs, or coordinates sometimes, it's always x comma y. Okay? So if we're given 2 points, point 1, let's say point 1, we say that, okay, the x coordinate for point 1 can be x sub 1, y sub 1, okay? And we say point 2 can have the coordinates of x2, x sub 2, and y sub 2. Okay, so we have 2 coordinates, and we have the x coordinate and the y coordinate for both. Okay, so the slope formula is going to be m is equal to, now remember, it's rise over run. So if we look at rise, okay, rise is simply the difference between our y values, right? It's the difference between our y values. So rise can be represented by doing y2 minus y1. Okay? And for run, right, if we look at run is just the difference between our x values, right? So our x coordinate here and our x coordinate here, we just subtract them to find the difference. Okay, so that means our run can be represented by x2 minus x1. Okay, so you'll get the hang of it once we do a couple examples. All right, so, oh, and remember, it's always important to simplify your answer. So if you end up with a ratio and that ratio can be simplified, you better simplify it, okay? Alrighty, so let's try question 1 here. So we have 2 points, right? These 2 points create a line. So we're going to call this one, whoops, is it going to work for me? Call that, just this one. All right, so we're going to call that x1, y1, right? We're going to call that point 1. We're going to call this point 2. So x2, y2. Okay? So let's calculate m. So we know that m, actually I'm going to give myself a bit more space by writing over here. So m is equal to y2 minus y1 over x2 minus x1. Now, we have to absolutely be careful when we are substituting in the values. It is so easy to get mixed up and put the numbers in the wrong location. If you put the numbers in the wrong location, you're not going to get the correct answer. Okay? So, let's have a look. So, what number should I substitute in for y2? Well, y2, right, is going to be 3. So let's put that in, 3. Okay, minus y1. Well, what are we going to put in for y1? y1 is 1. So 3 minus 1. Okay. All right. For x2, what number are we going to put in? Well, x2 is 4. So we'll put 4. 4 minus, and then x1 is here, x1 is 1 also, so 1 here. So once we're sure that we put the numbers in the correct location, we just calculate it. So that becomes 2 over 3. Can I reduce that fraction? No, I cannot. I cannot reduce that. So I'm going to put a nice square around it, whoops, to show that that is my final answer. Okay, so this means when we create a line that joins point 1 and point 2, right, the slope of that line is equal to 2 over 3. Okay, so let's try some more. So again, you don't have to do this, but I recommend you doing this because it helps you not get mixed up. Label the points, x1, y1, x2, y2. That way you can just keep it straight in your head. Okay, so m, we always start off writing the original equation. y2, y1, x2, x1. Okay, so for y2, that's negative 2. Minus, what is y1? Well, y1 is 4. Okay, now we're going to look at the x values. x2 is 10, and x1 is negative 2. So 10 minus negative 2. You have to pay attention to the negative signs, because look, that is a double negative. And if you don't notice that, you're going to get the wrong answer. Okay, so this will become negative 2 minus 4 comes to negative 6. 10 minus negative 2 becomes 10 plus 2. So that becomes negative 6 over 12. Now that can be simplified, right? That can be simplified to give our final answer of negative 1 over 2, right? Because that simplifies to negative 1 over 2. So that's my final answer, all simplified, all complete. Okay. Now, I'm not going to do all of them because I'd like you guys to have some practice, but I do want to make sure that you guys pay attention to when you have positive and negative numbers in your coordinates. Okay, so maybe let's do, question 3 has a few negative numbers, so let's do question 3, and then what I'm going to do is I'm going to leave the rest of this page for you to complete. Okay, so I'm going to do question 3. So, first, label them, right? X1, Y1, X2, Y2, just to keep it straight in your own head. Okay, so M is equal to Y2 minus Y1 over X2 minus X1. Y2 is negative 5, Y1 is 5. X2 is negative 8, X1 is negative 4. So negative 8 minus negative 4. Okay, so our numerator becomes negative 10. Okay, our denominator becomes negative 8 plus 4. So that leaves us to negative 4. Now this can simplify, okay? First of all, we know that negative over negative gives us a positive, but we also know we can reduce that fraction to 5 over 2. Okay? So there you go. That's our slope here. It's a positive slope. All right. Okay, so I will leave these questions 4 to 10 for you to do. Let's see what else we have here. 4 to 12. Okay. And we're going to try a couple of these other question types, so called going backwards. Okay. So, for example, sometimes you must complete the ordered pairs using a given slope. So sometimes you're told the slope and you're told one of the points, but you're missing a coordinate of the second point. So, for example, let's do this together. Whoops. Okay, the slope of a line passing through the points negative 5, 6, and 5, something. Meaning we don't know that y value. That y value, right, that is unknown. Okay? But we do know that the slope is negative 4 over 5. And what we want to do is we want to find y. Okay? Well, I mean, it's similar to what we were just doing because we still have an equation, right? Here we have an equation where our unknown is m, okay? But down here, we have m, and all we're trying to find is y. So again, we have an equation where we're only missing one variable, so we can solve for it. So let's start off with our slope formula. M is equal to y2 minus y1 over x2 minus x1. Okay, we know what slope is. M is negative 4 over 5. So we replace m with negative 4 over 5. Okay, y2, so I'm going to call this point 1. So this is x1, that's y1. I'm going to call this x2, and this unknown, well, it's going to technically represent y2. Okay, So again, y2, I don't know what it is. It's my unknown. But I do know what y1 is. y1 is 6. Okay. x2 is 5, and x1 is -5. So we get that double negative. Okay. Now let's be careful. So let's leave our left-hand side alone for now. It's still -4/5. Let's leave our top, and let's simplify our bottom. So again, that becomes 5 plus 5, which is 10. Okay, we're not done yet. But look, at this point, we have an equation. And the only thing we don't know is y. So we isolate for y, just like any equation we're trying to solve. Isolate for y, meaning get y all alone. Okay? So the first thing I would do is I would multiply both sides by 10. Okay, so I would have 10 times -4/5 is equal to y minus 6, right? Okay, now I'm just maybe going to do a simple simplifying. So that becomes 2 times -4, which is -8. And then finally, we simply rearrange the equation, bring that -6 over there. So we end up with y is equal to -8 plus 6. So y is equal to -2. Okay? There you go. Okay. So, let's see. Maybe we'll try one more of these ones, but I'd like you guys to try the rest on your own. And I will, of course, be posting the final answers so that you can check. Let's do one where we have to solve for x. So I'll choose 14, okay? So again, start with the general formula. M is equal to y2 minus y1, x2 minus x1. And let's label our points. We're going to call this x1, that y1, we'll call this x2, that one y2. Okay, so y2 is -7. y1 is -4. So minus -4. x2 is unknown, right? So let's just leave that as x. x1, however, we do know, and it's 0. Okay. And finally, we also know m. We know m is 3/2. Okay, so again, we have an equation where we have one unknown, and we need to isolate for it. So let's just simplify first. So we'll leave this side the same. There's nothing to simplify here. Okay, but let's simplify this top, the numerator here. So that's -7 plus 4, right? Because it's double negative. So -7 plus 4 brings us to -3. Okay, and x minus 0, well, that's just x. Okay, so we need a bit more space. I'm going to bring my work over here. All right, now remember, I cannot solve for x when x is on the bottom. So I need to bring that x over to the other side. So I'm multiply both sides by x. So then I get x, oops, that's fine. X times 3/2 is equal to -3, right? All I did was multiply both sides by x. Now I'm going to multiply both sides by 2 to get rid of that 2 on the bottom, right? So that leaves me with 3/2, right? So times 2 times 2, we get canceling it out, okay? And then I'm also going to divide both sides by 3, right? Divide both sides by 3 so that I can also get, whoopsie, this to cancel out, okay? So I'm left with x is equal to -2. Okay, so therefore the x coordinate, right, is -2. And that would be our final answer there. Okay, so again, this is a lot of algebra. This is rearranging equations, right? So it's a lot of skills that we've used before. Now, I want you guys to complete this, this for practice, but also you're going to have a mini assignment to do with this as well, okay? Similar to the mini assignment for lesson 3.3. All right, so that's it. I hope everything made sense for you guys and you're ready to try this on your own. Okay, take care.